In this tutorial, I will explain recurrent neural networks in simple terms. So recurrent neural networks is nothing but a neural network that's repeated over and over again. So let me draw the first block, or the block of the recurrent neural network. So we have W in -1, and here we have the hidden state from the previous word. And so, as we said, it is kind of neural network. So it is, or it looks something like this. Okay. So now the RNN, or the neural network here, is characterized by two inputs. The n-1 word in the given sequence, and the hidden state from the previous word, n-1 hidden state thus far. So first of all, any word that that will be processed must be in a vector form. I mean, it must be assigned an embedding. And we know that there are a lot of embedding techniques, for example, word-to-vec. So assume that we used word-to-vec here to assign embedding vector to each word. So now the hidden state from the previous word also in a form of a vector. So the first step in the RNN, in order to generate, because the goal here is to generate, or is to generate or predict. So generate or predict the next word in the sequence. So in order to leverage the information about the previous word in order to predict the next word, the first step is to concatenate the two vectors. So we take the vector of the W in -1 and concatenate it with the hidden state from the previous word. So it will be it will look something like this. So we have the vector for W in -1, and we sort of sticking that to the other vector. So this is the the hidden state from the previous word. And so what will happen with this vector, we will pass that to this neural network, which is the RNN network, right? Which is simple neural network. So we pass that to this neural network, and we will get the hidden state for the next word. So let me draw it for simplicity here. So we will pass this concatenated vector to a neural network, and we will predict the hidden state of the next word, which we can draw here, HN, and then we will pass this hidden state to other MLP with softmax. So we know that softmax is to kind of generate probability score that sums up to 1. So now we will have, as we said, softmax that all for example, all the words in the vocabulary will be generated some probability score using this, and then we will get the WN, and this WN will be used in the next step, which is will be the current word. So we will take this WN, and then we will do the same process as we did with W in -1, but in this case we will take the current word, which is WN, that's generated or predicted in from the next step, with the HN, and then we do the same process. We will generate n -1, and then we will have softmax, and then we will predict the wn minus 1, and we do the same for all other words in the sequence. So we can see how the hidden states in general, how the hidden states of, for example, in this case from the previous word, and then this one from the previous, and this one from the previous, so on and so forth, feeds into the model to predict the nth word. So we have, we kind of having some like memory of, the information of the previous word in order to predict the next word. So next we will talk about, other variant of recurrent neural network, which is used to solve some of the problems arises from this architecture.